Hi, and welcome back to Neil's Notes. In the previous video, I took you through a set of steps to build a clock being displayed in the terminal, which we called console clock. In this video, I'm going to follow a set of steps to add the current weather information to that clock. And that will look a little bit like this. So I've got the current weather displayed here in Sydney, which is close enough to where I am, next to the time. So in order to do that, I have a set of notes that you can follow along. So if you go to neilsnotes.net and find the console weather notes, this extends the console clock, as it says here, to create a clock that has weather in it. Now, in order to get started, you're going to need an API key for Open Weather, and all the links are here in the notes. And you'll need to go to openweathermap.org/API, and here you can sign up for a key, and you'll need to keep that key handy. Now, I'm not going to share my key with you in this video, so you'll have to create your own key. If you're doing this in a classroom or a school type situation just to experiment, then you could probably get one key that you could share amongst your class for the time that you're building this exercise. If you're using it for commercial purposes, you absolutely should get an Open Weather account and pay for a subscription. If you don't, your key will actually expire after a certain number of uses anyway, so you will, for a commercial application, absolutely need to pay the Open Weather Map folks for a subscription. Okay, so let's get started. I'm doing this on my Raspberry Pi once more because I can. But this is .NET 6, C#. It'll run on any platform supported by .NET 6. So once again, that's Linux, that's Mac, that's Windows. And I am going to carry on from the console clock that we started in the previous video. So let's open up a terminal. Let's just zoom in a little bit more so that it's easier for you guys to see. And if you remember, we have in our documents folder a dev folder, and in there we had our console clock. And this is where we're going to start doing our work. So let's start by loading Visual Studio Code for our console clock, and then we can start extending it. Great. So now we've got Visual Studio Code with our program open. Let's go to the Cs Proj file. Now this file defines how our project will get built. And you can see here it's using the Microsoft.NET SDK. It's building an exe, that's a program, and the framework is .NET 6.0. And I've got some other flags, implicit usings and nullable, that are enabled that make life a little bit easier in .NET 6. So in order to make this work, this project work with the Open Weather API, you're going to need to add a reference to the project for the library that we're going to use for the Open Weather API. Now there is what's called a NuGet package, so we're going to need to create an item group. Now a NuGet package is a bundle of libraries, or it could just be one library, that's delivered using a packaging API called NuGet. And the package we want, so package reference, and the include defines what the package name actually is weather.net. Now we can put a version in here as well if we want to be explicit to a version. So we could put, for example, version 1.1.0, and now we're tied to that version of weather.net. And weather.net is a .NET wrapper that makes it easy for us to call through to the Open Weather API. And I just noticed that this is missing the close element, so important to make sure every open element is matched with a close element. That means that it's closed, and the package reference, the closed element, is actually within the end, so it's not got another closed element. So it's important to get that piece right, otherwise of course it won't build. So save that file. To start using the Open Weather API, we've added the package. We also need to add a key somewhere, and it's often a good idea to have a separate file for putting your secret keys. Now, for the sake of this note or this exercise, we're just going to create a new class file, which we will call keys.cs, which we can reference. However, in a production environment, you would probably want this in a configuration somewhere, and in a commercial production environment, you would probably use some form of key store to manage where your keys are, and so your keys are not available directly in the code. Anyway, to get this moving forward now, we're going to create a new internal static class that we're going to call keys. Now, internal means that it's only available within our program. We're not going to expose this outside. And static means that it's only ever created once, and it's not recreated every single time. So now we will create an internal const. So that's a constant string. That means it doesn't get changed again, called open weather. And in here, you'll need to paste your open weather key. So your key goes here. Now, I'm not going to share my key with you. You can get a key, as I said already, from the openweathermap.org site, and then you can put your key into your keys class here. Great. Okay, now we can start thinking about how we're going to display that weather. Now, if you're working from the console clock, which you should be, you'll remember we had all these different byte arrays to represent the different digits and the two dots that are flashing in the clock. Well, I'm going to create another character here, which is Celsius. Now, of course, in the part of the world where I live, and I guess the majority of the world, we measure temperature in Celsius. Of course, you could measure it in Fahrenheit, but if you look at the ones here, it's making a little degree symbol and a C. You could, if you wanted to capture your weather and display it in Fahrenheit, of course, make a little F there instead. To use the Open Weather API, we're going to just do something which is kind of a little bit old school, but it makes it very explicit. We're going to add a using statement to our program CS for the Weather API code. Now, this is telling the compiler that these namespaces, weather.net and weather.net enums and weather.net models weather model, should be available within the code directly without having to fully explicitly use the namespace. So we could get away without doing this. It just makes the coding a little bit easier for us going forward. Then let's scroll down to the actual code. Now, above the while loop, which is doing, I guess, the work of updating the time in our console clock, we're going to create a weather client object. We will call it client. So the weather service is really, you can think of it as a web service. It's a service online, and we're going to create a client to access that service. And so we're going to create a new weather client, and that will take a parameter of the keys in that key class that we created earlier. And what was the key? Was called open weather. And then if we want to get the current weather, we can get the weather model that represents the current weather. So we'll call that current weather equals client. So using the client, get current weather, and then we can put the city name here. I'm going to put Sydney, New South Wales, but of course you can put your own town and state here. And then it's going to ask for some other details. So we can ask for the measurement. So how do we want the weather measured? And that will be in measurement metric. And if you if you wanted imperial, you would put imperial there. So this is an enumerated type in the weather enums, and will give us the weather in Sydney, New South Wales as Celsius, so in metric measurements. Then where we've displayed the weather or the time, we can start thinking about putting some code in here to display the weather. So let's add the console foreground color to be equal to the clock color, because what we're going to do is display the city and some information about the weather. We will increment our position by the digit width again, so we're moving along from where we're displaying the time to display the weather. We'll say console set cursor position, and that will change where we want it to be to the new position and clock top. And then here we could output, so we can do something like console.write, and we could output the current weather name or the city for the current weather. So we could do let's do $. That's tells us that in here we're going to put some code, and we want the value of the code displayed as a string. So we can do current weather dot city name, and that will display the name of the city. And then we want to set the cursor position again to below that. So let's just go down. Now remember, each of the digits in the time was 7 characters high. So we're going to set the cursor position to cursor top plus 6, and that'll put it at the bottom line. And then instead of city name, let's put a summary of, so the current weather.weather is an array of coming up or information about the weather, and we're just going to put the first one and the title of that below the city name, so that we kind of have that, the city, some information about the weather, and then we're going to display the digits for the temperature. So then we want to increment the position again. And now let's display the digits, and we're going to take the weather. So I'm just going to cast the current weather temperature to an integer, because it may well be a floating point or a double, and I'm not very interested in it being 0.76 degrees something. Just the fact that to the nearest degree is fine. So the current weather main temperature, and then we will cast that again to a string, because if you remember, the display digits method that we created takes a string. Now, I think I've got another bracket I need to put in here, so we're taking the integer to a string. We are actually going to move it back to an integer again, but for now we already know our display digits does the work of taking a string with 2 digits in it and displaying it. And then we could draw our Celsius, or if you wanted to do Fahrenheit, you could do that. But so we've displayed digits, and then we can add our Celsius indicator after that. So let's save that. To run this, we will open terminal, and just remember that you need a bit of space. If you remember from the console clock, you need a bit of space to display the digits. Now if I run this, it'll probably tell us that we haven't put a key in, because I've left the key from, there we go, it says the given API key was invalid. And so what you're going to need to do, if you just put this code in, is actually put in your API key. So now I've put in the API key, and we'll try again. And it should compile. And now, whoa, okay, so there's a little bit of a problem here. So you'll see it did flash up very quickly, and then it disappeared. So if I close this, it'll come back, but it's still got this background color problem. So one of the problems here is that we set the foreground color and the background color, and this has now changed the way that it operates. So we need to fix that. The way we can fix this is to reset the color after we have drawn the weather. Now you can see it's displaying the time and the weather, and of course if we stop this and go back to our terminal, we can .NET run from here, and there we have something that even looks a little bit tidier. Let's just give that a bit more space, and we can see running in the terminal we have the weather and the time being displayed. Now the time is being updated every second. The weather is only captured at the beginning of the program, and that now is static. And you could leave this running for 3 days and it would still have the same weather because we haven't updated it. So we need to think of a way of updating the weather. The other thing which we didn't do in the last video but is in the notes is we haven't in this program set the cursor visible back to true, which means now I don't have a cursor anymore. So we can fix that very quickly in our code by going down here, and when we finish drawing, setting console cursor visible equals true. And then the next time we run this, it should set the cursor visible back to true again when we've finished. And there we go. Now we have the cursor is visible again. So let's get back to the code and think a little bit about how we can update the weather so that it's usable if we left the clock running for a long period of time. But of course we don't want to update the weather every second. It doesn't really change that much. So we could think about maybe having a different way of updating the weather than the way we update the time. But let's just go back up to above our while loop and above where we're declaring the weather client, and let's just make things a little bit easier for ourselves. Whoops, that should be a string, and define some of the variables that we want to use for the weather directly in the code here. So if I, for example, define the weather city, then actually I don't need to put that here. I can have the weather city here. That's probably a little bit nicer, and it means I only have to define it once, because I'm going to want to update this based on the same city on a reasonably regular basis. The next thing we can do is we could set a period of time that we call our check weather period. Whoop. So that's how often are we going to check the weather. So let's just now say we're going to check it every minute, but we can of course change that. So we'll say 60 seconds is the amount of time roughly that we're going to check the weather. And then what we need to do is keep a track of how close to that are we. So we'll say the current period seconds is 0. So we start at 0 and we're going to count up to our check weather period, and then every check weather period we will check for the weather. Okay, so now what we need to do is we need to, in our while loop, we need to somehow increment every so often the weather or the check period, and if we hit a certain limit, which is our check weather period, so we'll increment the period seconds every time we do a loop, which is roughly a second, not super accurate but good enough for now, and every 60 of these loops we'll check the weather again. So what we can do here is, after we've displayed the minute, we can put some code in here that's if the check weather period, or actually why don't we do it the other way around, if the current period in seconds is greater than the check weather period, so we've gone through this loop more than 60 times, because the check weather period is 60, then we could update the current weather equals, so that we set the weather client to be client, and we can get current weather with the city name of our weather city and the measurement of, well, in this case we're going to stick with metric. So this will now update the weather, and once we've updated the weather, what we should probably do is set the current period seconds back to 0 so that we can start counting it up again. And then what we'll do is, whether or not we've done that, we will increment the number of seconds, or the number of loops really, just assuming that each loop is roughly around a second. And so what this will do is, as the time loop goes around, which is roughly a second, 60 times, that means it's gone over the number of the check weather period, then we will refresh the weather and reset that current time period. So once more, let's run this in the terminal. And it should compile and display, and we're probably not going to really see much difference now because, well, once a minute it's going to update the weather, but the weather doesn't change that much. And so in a production application or something that you're actually going to build for the real world, you would probably change that to a longer period. So if you consider it's roughly 60 is roughly a minute, 60 seconds is roughly a minute, you could do something like this. So maybe every 15 minutes or every 10 minutes you check the weather. And that would give us a more reasonable cadence for looking for the weather rather than every minute, which probably doesn't make a lot of sense for us. Now this program file that we've been working on is starting to get quite long, and it's really got almost everything in it for the code other than our keys. And when I look at it, I realize that what it has in it that's not really relevant to the core runtime of the program is these characters, each of these byte arrays that we defined. And so what might be nice to do at this point is refactor this again and put the characters into a separate file. So let's create a file called cars.cs, and in cars.cs let's create another internal static class which we will call cars, which matches. It's actually always very good practice to match the name of the file with your class name if you can. And then what we're going to do is we're going to go to our main program and let's copy out all of these byte arrays so they're not in the code directly and not getting in our way while we're working with the code. And we'll take that digit array as well. Let's copy that out, so Control X, go to our character arrays and paste it in. Now we're going to need to make this usable by the code in the program file, and we will do that by making each of these byte arrays a internal static. So we're going to use this same internal static on each of these byte arrays. So we could just copy and paste this in front of every single byte array. It's a little bit of work, but it won't take us very long. And if you had to do a lot of this, you might use find and replace, so you could look for wherever we've got a byte array defined here and just put this in front of it, but there's only 12 of them, so that's quite easy. We also need to do something similar with our digit array, so that's available outside as well. So you can install extensions into VS Code that will help you tidy up the code. And I installed an extension and then pressed Control I, and that determined that it could go through and reformat the code and make it look a bunch tidier. Okay, so that's cool. Our characters class now looks nice and tidy. However, we now need to go back to our program, which is referencing those characters, and use them wherever we've got characters being used. We're going to need to change that to use the characters in the cars class. So if we look through where we've got characters being used, let's have a look through. Well, it's not here because this is just the digits, but here we've got cars dots, and that's in the characters. Then we get the display digits minute, that's great. Then we get the weather, and then we're writing out the city name and the weather details. And then we're writing out the temperature, again that's just digits, and then we're writing out Celsius, and that's now in our characters class. Now in the display digits, the digit array is also now in our characters class. If we look in our characters class, we now have this digit array here. Now actually what we probably should do is turn that into a capital D, because it's now in the class, it's not like a local variable in the program, and then fix that to the digit array. Great. So now it should be fine to pick up and draw through these characters. So that was a refactoring, just simplifying the code. Making less code in each file to read is always a good idea. So let's see if we broke anything. So one of the things you should always do after refactoring is check you haven't broken anything. And so far looks pretty good. And the temperature has increased by 1 degree since we did that work. And we're on target to have our finished product. So let's just stop this and go back to the terminal and just make sure it all runs nicely there as well. Great, looking good. So we can now just have our terminal window running as we're working on our machine. And of course I've been doing all of this on a Raspberry Pi again, but this will work on any machine that uses or that supports .NET 6, so Linux, Windows, Mac. Thanks for watching another episode of Neil's Notes and following along. Hopefully you learned something from this. We extended the console clock to now display the weather in our console. And that's kind of brings us to the end of what I wanted to do in the console for now. For the next video, I'm going to look at how we can use the camera on the Raspberry Pi. So it's going to be a bit more specific to coding on a Raspberry Pi. I hope you enjoyed this. I'll hope you join me for the next adventure into coding on a Raspberry Pi. Catch you next time. Bye.